I've been fascinated about scientific advances in nanotechnology, but I've been fascinated as an engineer. So chemists have figured out how to make new materials that can have many different colors thanks to the size of nanomaterials. And they figured out how to make molecules do things that no natural molecule has never done. But then there's a need for engineers to translate these into devices. And so in my research, I translate the fundamental scientific innovations of chemists and of physicists into real devices. So for example, we've made a new camera that will go into next generation smartphones that can see infrared light, invisible light, that today's cameras simply can't see. It comes from engineering practical devices, but all built off the advances of some beautiful nanoscience. So when I start a project within my research group at the University of Toronto, my first thought is always on the fundamental impact. It's about, is it a new idea? Because I know I'm actually creating my own pipeline. Some of the ideas we work on could be beautiful science, but not every one of them is going to translate into a big market or a market that's ready for disruption, a market that requires change. And then as the project progresses, we see whether our new idea is working. We see whether it really translates into a technology. And we ask, could this impact or really transform a $1 billion existing market? Could it turn it into a $10 billion one? So our work on image sensors turned out to be one such market where Envisage, my startup company, is really changing the way things are done within the light sensing market. And Exogenic, which is a company that I'm a co-founder of, has determined that a technology that I and my collaborators at the University of Toronto discovered on sensing DNA could really change the way in which disease is diagnosed. Hugely important problem in medicine and clinical care, and also a very large business opportunity. Yeah, so I think the two most important qualities for a student, an undergraduate or a graduate student, working in any frontier area, could be nanotechnology, could be deep learning, in which U of T has played such a pioneering role, could be biomedicine. The first quality is fearlessness, and the second is entrepreneurialism. So by fearlessness, what I mean is that these areas are changing all the time. They're moving faster than undergraduate education is moving. So with your undergraduate education or your doctoral education, you're getting training in certain areas, but when you go do your research, when you go start your company, the landscape will have shifted enough that you're picking up, you're inventing, you're improvising as a researcher, as an entrepreneur. And the second point, which I described as entrepreneurialism, means that you need to be really ambitious and really a thought leader. So in my experience, people who follow, who look for existing trends and who sort of see how they can follow them and track them, are not going to be the ones to create new companies, and they're not going to be the ones to attract venture investment. Ones who define a new vision are the kinds of students, faculty members, graduate students who we have at the University of Toronto. They're out in front, and they have a Pied Piper effect. They have a Pied Piper effect wherein others, students, scientists, researchers, engineers, technicians, business people follow them and follow their vision. And that to me is how you create disruptive change and how you build businesses. Yeah, you know, in my experience, the PhD is becoming a more and more popular degree. Of course, it has been and it will continue to be the base for becoming an academic leader, for becoming a professor, for running your own research group, for teaching the next generation of students, which is an incredibly rewarding career. But increasingly, it's also the base of leadership in industry. And that could be a technical base. So our students are getting PhDs to go work at Google and Apple, Facebook, Amazon, IBM, GM, Bombardier. So they're going out into the workforce, but the workforce demands really profound training, deep expertise, but also this entrepreneurialism that I described. And the doctoral degree is a perfect platform with which to do that. And the other thing is that it's also a real platform for change over the course of your career. And so if in the first 10 years of your career you want to be an independent technical contributor, and in the remaining 50 years of your career, you want to be a CEO or a CTO or a CFO or chairman of the board, or you want to be a venture investor, or you want to be a philanthropist. The doctoral degree is an incredibly versatile platform for doing it, really unlike any other degree. Yeah, so graduate students are really the heart of the research enterprise. Professors are advising, but it's master's and doctoral students and also postdoctoral fellows who are doing the actual work. So actually, I'll give an example of a wonderful postdoctoral fellow that I work closely with. He's in my group. His name is Ankit Jain. He did an undergrad degree at an IIT, his PhD at Carnegie Mellon University. Then he came to the University of Toronto to join my research program. And actually, as soon as he joined me, he was scooped up into something called an IBM postdoctoral fellowship, which supported him and also allowed for collaboration and a lot of real corporate learning that happened with IBM. So Ankit and his colleagues have made huge advances in the area of computational nanotechnology, so predicting what the experiments will tell us before the experiments are done. It allows us to accelerate our research. And now Ankit and his colleagues are right at the leading edge of using machine learning and deep learning to accelerate computational material science for nanotechnology. So they're right at the frontier. And that's exactly where U of T doctoral students, master's students, and postdocs should be and are today. Yeah, so the funding for graduate students, especially international ones, comes principally from the research grants of the doctoral advisors. So when a student applies to the University of Toronto for their graduate studies, they'll apply to the university, they'll apply to a department, and then making the connection to a prospective group of graduate advisors is very important because there's a matchmaking that happens there where the student and the advisor see one another's expertise, see one another's interests, get excited about working together, and where the graduate advisor decides to deploy some of her research funding to support the student. Yeah, so people who get degrees from the Department of Electrical and Computer Engineering at U of T, which is my own home department, go on to an incredible diversity of different jobs. So many of them take up positions within the Greater Toronto area where there's huge opportunities for employment. For example, at IBM, which has over 5,000 positions doing research, advanced engineering, some very exciting work in software happens at IBM. Many of them go and work at leading multinational companies. Google has a presence in Canada, Facebook, Amazon, Tesla just opened a presence in Canada. So all of the leading tech companies are kind of flocking to the Toronto area because of the great environment, the great city that it is, the financial environment, and the tremendous talent that the University of Toronto has attracted to the city. So really, with the University of Toronto degree, the options for the student, for the graduate, are without limit.